Hello students, my name is Dr. Neeraj and today we are going to discuss about the transportation model and how do we solve or how do we optimize this model for reducing the cost. So इसमें what I want is that I will try to do it with you. I'm going to write the problem slowly and what I want from you is you practice this along with me. So let us start doing. Now first I will write this particular problem over here. What I want is you also write along with me. That's why I'm writing like this slowly. So you have to practice along with me. This problem is there. First, we'll make the table. Yep. Origin and destination we'll write over here. Origin 1, origin 2, origin 3, origin 4, and this is the demand. Here we will write destination 1, destination 2, destination 3, and this is the supply. So how do we check whether this is a balanced model or it is unbalanced? So we are doing it for balance. That means the supply and demand will be same. So from origin 1 to destination 1, cost per unit is 2. From origin 2 to destination 1, the cost per unit is 3. Like this we are writing all the costs. 3, 4, 6, 4, 1, 7, 2. Then total demand for this particular destination 1 is 7, then 9 for 2 and 18. Supply for the origin 1 is 5 and then respectively 8, 7 and 14. Now if we have to see whether it is balanced or not, we have to add these supply 5, 8, 7, 14 and 7, 9, 18. When you total it, you will see that the total is 34. So this will be a balanced model. This is because it is 34. So because both supply and demand are equating to 34, so it is a balanced model. Now, students, we have to reduce the cost. We have to decide will how much we have to transport from origin 1 to destination 1. So this particular method is northwest method. So north is to the top and west is to the left side. So the first corner towards the northwest is 2, that is O1 D1. So 2 is the what we have to focus. We always have to focus on northwest. So for this particular cost, what is the supply? 5, if you can see that. And what is the demand? 7. So what we have to do is we have to write what is the maximum or what is the possible amount of goods can be transported from O1 to D1. So if you can see that 5 is the maximum supply and 7 is the maximum demand. तो अगर 5 supply है and demand is 7, तो how much is the maximum we can transport? Can we transport 7 when the supply is 5? 5 में से 7 हम निकाल सकते हैं क्या? इट्स नॉट पॉसिबल. सो मिनिमम कौन सा है दोनों में से? डिमांड और सप्लाई में मिनिमम इज सप्लाई. 5 से ज़्यादा हम इसमें ट्रांसपोर्ट नहीं कर सकते हैं. तो व्हाट वी विल डू इज विल राइट हेयर 5. विल राइट 5. एंड देन व्हाट वी डू विल सब्ट्रैक्ट दिस. क्योंकि एक बारी पांच हमने ओरिजिन वन से डेस्टिनेशन वन में पांच गुड्स को ट्रांसपोर्ट कर दिया है, तो दैट मीन्स सप्लाई इज नाउ ज़ीरो. इज ऑलरेडी ट्रांसपोर्टेड. एंड डिमांड पाँच तो जा चुके हैं, तो डिमांड रिमेनिंग डिमांड इज टू. सो दिस इज वेरी क्लियर. और जहाँ पे ज़ीरो हो गया उसको हम लाइन को काट देंगे. यहाँ पे ज़ीरो है बिकॉज ज़ीरो नाउ द ज़ीरो and supply is zero. This does not have any relevance, this particular row. So what I will do is I will cut it. Now again I have to see the northwest. Next northwest is 3. This one. Now tell me 2 and 8. Which one can go? 2 is the maximum which can go because demand 2 से ज़्यादा है ही नहीं. Supply may be 8 but demand is 2. So more than 2 we cannot send. So what we will do is we will first write here 2. And then जब 2 already transport हो गया है, demand has been met, so it is become 0 and this 6 is left. Supply 6 is left, 2 is already gone. So 0 again, this line 0 is there. This has no meaning now because demand is 0. We don't have to consider this particular path. Now what is the next one? Northwest. It is 3. This one. So 6 and 9 for this particular thing between 6 and 9, which is the lowest. 6 is the maximum supply we have. So we cannot fulfill the demand of 9. So 6 is what we can transport. तो यहाँ पे 6 आ जाएगा and then this will become 0 and 6 minus 9 is 3. And as I told you, rule is once when supply is 0, nothing can go from this path, so we will delete this also. This is also deleted. Now what is left? Northwest 4. 4 is what we are looking at now. Between 3 and 7, what can go? 3 can go. So we write here 3 and we make it 0. And 7 minus 3 is 4. So 0 we have to cut it as I have told you. So this is also gone. The next northwest corner is 7. This one. 4 and 18, which is the lowest one? 4 is the lowest one. And we make it 0 and we make it 14. And again we cut this 0 over here. Now again 2 is the one northwest corner we are looking at. 14 minus 14. 14 14 is same. So minimum is 14. And then we make it 0 and we make it 0 and we cut this also. Now what is the solution for this particular model is we have to, I don't want to change the page. So what we will do is first we will multiply 2 multiplied by 5. What is this? This is cost. This is the number of units. This is what we are doing for all. Plus 3 into 2. This 2. Plus again this one. 3 into 6. Plus 1 second. So remaining is 4 plus 4 into 3 plus 7 into 4 plus 2 into 14. So this is the solution for this particular problem. And then what we do is I'm just taking this over here. So 10 plus 6 plus 18 plus 12. Now the total is 16, 10 plus 6, 16 plus 18 plus 12 plus 28 plus 28, which is equal to 102. So this is a solution for the transportation problem. So minimum 102 rupees is required for transporting all these goods, keeping the supply and demand constraints. So this is the optimized solution, which is the minimum cost required for this transportation from origin to destination. So thank you very much for watching this tutorial, and I hope you have understood.